Hello everyone, welcome back to another lesson on measurement. Today we are going to be looking at volume. Before we get going, let's have a look at our concept map for today. Cool everybody, so before we get into volume, I am going to define what a polyhedron is. After I've defined that, I'm going to define volume. Shortly after defining what volume is, I'm going to show you how we can actually calculate the volume of rectangular prisms, cubes, and cylinders. So, what is a polyhedron? A polyhedron is a three-dimensional figure with four or more flat surfaces. So, everyone, a polyhedron is essentially any three-dimensional shape. We know that we get two-dimensional shapes, which is essentially if I were to draw a circle or a square on a flat piece of paper. That is two-dimensional. Three-dimensional shapes are essentially shapes that I could hold. So it could be a ball, it could be a can of beans, could be a box of chocolates. But essentially, a polyhedron is a three-dimensional shape that has multiple surfaces. Great, let's go to the next slide. So let us define volume. So the volume of a three-dimensional shape refers to the capacity that the shape has. The volume of a three-dimensional shape is determined by working out the area of the base. And once we have the area of the base of the object, we then multiply it by the perpendicular height. So please just make sure that you're comfortable with the idea of me working out the area of the base of the shape, and I multiply it by the perpendicular height. I'm going to put a red box around perpendicular because, just a reminder, with some three-dimensional shapes, I have a slant height. My slant height is not always my perpendicular height. So please make sure when you are calculating volume that this calculation is the area of the base times the perpendicular height. Also, just a little note that you might want to say to yourselves is if I'm working with shapes that involve perpendicular sides and 90-degree angles, we must look out for Pythagoras because we know that Pythagoras is common when we are working with right angles. Great, let's go to the next slide. The first shape that I'm going to talk about finding the volume of is the volume of a cube. So the volume of a cube can be found by multiplying the area of the base by the height of the cube. And we know that this is going to work, everyone, because cubes have 90-degree angles at each of their corners. So this height will be a perpendicular height. And we've said that we're going to find the volume of the shape by first calculating the area of the base. And my base is this bottom square. And what is the area of the base? Length times breadth, but because it is a square, all sides are equal. So the area of the base will be length times length. Then I multiply it by the perpendicular height of a cube. But again, because this is a cube, all of the sides are equal to each other, so my perpendicular height is actually going to be L again. So L times L times L is going to be the volume of my cube, so my volume is L cubed. Great, everyone. I hope that everyone is with me so far. So I'm going to say this a few times just so we make sure that we understand. The volume of a three-dimensional shape is calculated by finding the area of the base times the perpendicular height. For this one, I had calculated the area of the square at the bottom, and I multiplied it by the height of the cube. Great, let's go on to the next slide. Great, guys, so the next one is the volume of a rectangular prism. We first need to calculate the area of the base, which is the bottom rectangle. So we can see the base of this particular box is this bottom rectangle. So I'm first going to calculate the area of that rectangle. Once we have established this, we multiply the area of the bottom rectangle by the perpendicular height. Again, a rectangular prism is made up of rectangles, and rectangles have right angles present at all of their corners. So we know that that angle will be 90 degrees, which means that h is my perpendicular height. So let's write it as a formula. So the volume will be equal to the area of the base, which is length times breadth. And I'm going to be multiplying this by the perpendicular height. So the volume of a rectangular prism is length times breadth times height. Let's go to the next one. So we are now going to calculate the volume of a cylinder. The volume of the cylinder is found by establishing the area of the circular base and then multiplying this by the height. Again, it's going to be the perpendicular height. We can see this perpendicular height has been labeled specifically because we have this right angle present. Now, if I'm first going to calculate the area of the circle at the bottom, I have to use the radius. And just a reminder that the area of a circle is pi r squared. And I've now got the area of my base circle, and this is being multiplied by my perpendicular height. So it's going to be pi r squared times h, which I can also just write as pi r squared h. Just a note about this one, everyone, is please make sure that you are actually substituting in your r. In some questions, you might be given the diameter. We want the radius, and the radius is always half of the diameter. So the volume of a cylinder is pi r squared h, where r is the radius, not the diameter, and h is the perpendicular height. Great. After the break, we're going to be looking at how these volume formulas can help us solve some examples. See you soon.